For question 2, we know the density function of xy equals b. And the question A asks us to find b, so that's the function above is a valid joint density function. It is a valid joint density function, so the integral of fxy should be equals to 1. Here, this should be 1, and we can clearly see that this should be b times this. It is definitely, and this part should be the area of this circle, which is pi. So we know that b should be 1 over pi. So for question B, we need to find the expression of x and the expectation of given y, x, and the expectation of giving the variable y, x, and so on. We'll calculate them one by one. First, we calculate the expectation of x. This should be the integral from -1 to 1, -1 to 1, x, 1 over pi, with respect to dy and dx. This should be equals to 1 over pi times the integral from -1 to 1 and x, the integral from -1 minus x squared and 1 minus x squared root 1 dy dx, and this should be equals to 2 over pi of and as you can see here, this is an OR function, so this should be equals to 0. And we know the density function of xy, which is 1 over pi, and we can calculate the density function of y. This should be equals to -1 minus y square root 2 1 minus y square root of this, and this should be equals to 2 over pi 1 minus y square root, and we calculate the density function of x given y. This should be equals to this over fy, and this should be equals to 1 over 2 times 1 minus y square root, and the expectation of x given y should be equals to x times 2 1 minus y square root, and this equals to from 1 minus y squared to 1 minus y squared of x with respect to x, and this is an OR function. So the final result should be 0. So we know that the expectation of x given y is 0. So for every y, this should be 0. And similarly, we can calculate that the expectation of y should be 0 too. And the expectation of y given x should be 0 too. This is just like the things we did here above due to the symmetry, so I will not do it again. It's very similar with the x. Here. And we calculate the expectation of xy here. Oh, this is question C. This should be the integral from -1 to 1 times the integral from -1 minus x squared to 1 minus square xy dy dx. And this is an integral, this is an odd function, as you can see, so the final result should be 0. And we can see that expectation of xy is 0, and this is equals to the expectation of x times expectation of y. So x and y are uncorrelated